Hey, good morning, everybody. This is Mark Raimondi, Chief of Staff of Silverado Policy Accelerator. Thank you for joining us this morning. We are going to be briefing our new report that we just released today called Foundational Fabs, China's Use of Non-Market Policies to Expand the Role in the Semiconductor Supply Chain. We are going to have a Q&A function. It is in the app, so look for the Q&A button and submit your questions whenever you want. I'll be taking those questions at the end of the briefing and asking our panelists and going over them. In the event event ends before your question's answered, you can email us at info@silverado.org. So for those of you who may not know Silverado, we are a geopolitical think tank focused on accelerating bipartisan solutions to pressing geopolitical challenges in trade, cyber, and environment. This morning on the call with me is our founder and executive chairman, Dmitry Alperovich, our CEO and executive director, Sarah Stewart, and Andy David, who is our senior director for research and analysis. I'm going to turn it over to Sarah. And again, the question function, the Q&A function is in the app. Please use it. And Sarah, the stage is yours.
Thanks, Mark, and welcome, everyone. Silverado has been working extensively on semiconductor issues for the last few years, and we probably worked with many of you who've joined this webinar. Our objective is to help position the U.S. and allies as competitively as possible in this complex supply chain. We've supported the CHIPS Act investments in the United States and the guardrails to protect that investment. We've supported the administration's work on export controls on the leading edge, and we commend the work that the U.S. government has been doing to try and promote U.S. and allied competitiveness while also addressing national security concerns. Over the last 6 months, we've done a deep dive to look at how the Chinese government's non-market practices, such as massive industrial subsidies, are driving it to double down on investment in legacy, or what we call foundational segments of the chip supply chain that are not covered by export controls and guardrails, and are intended to reduce reliance on the US and help China indigenize its industry. We're seeing the Chinese government use the same playbook of market distorting practices that have gutted US industries in the past, such as solar and steel. From IP theft, economic espionage, to non-market state aid packages, China's expanding its role across the value chain, from design to fabrication to assembly, test, and packaging. China's capacity expansions for foundational chips is particularly alarming, as this segment accounts for 3/4 of global foundry capacity, and China is on track to dominate production in this segment. This capacity expansion, which is not necessarily tied to true demand, is designed to help the Chinese firms outcompete non-Chinese firms on price and non-price factors and capture market share in China and in other global markets. We're already seeing evidence of this, as you'll hear today. We don't want to wait until our CHIPS Act investments are undermined, or God forbid, U.S. fabs are idled in whole or in part, or jobs are lost, as has been the case in other industries. So this report is a call to action that we must start tracking these troubling trends and implementing policies and other measures to turn the tide. Before we go into the report's findings, I'm going to turn to Dmitry, who can talk a little bit about the importance of foundational chips.
Thank you, Sarah. So one of the things that you may notice as the first thing in our report is how we're discussing foundational chips. This is a change in language that we are working with policymakers and across industry to adopt, because the existing language of legacy nodes or mature nodes is indeed a misnomer. In fact, there is nothing legacy or mature about most of these technologies, since they're actually quite advanced, even if the node sizes are much higher than is typically used in advanced or leading edge nodes. There's a lot of high technology that goes into semiconductor manufacturing, and shrinkage is just one of the factors that characterizes what advanced manufacturing is. But beyond the fact that these so-called legacy or mature nodes, or again, as we say, foundational nodes, are quite advanced, there is their criticality. these nodes are absolutely essential for national security. First of all, they're essential for weapons platforms. Virtually all weapons these days are manufactured with these foundational chips. For example, Global Foundries has a contract with DoD to provide the strategic supply of those chips, which is a 45 nanometer silicon on insulator platform. No product, including lots of national security applications, can actually be built without foundational chips. So for example, if you take a modern iPhone, there's about 3 advanced or leading edge chips in that phone: the processor, the memory, and the chip typically from Qualcomm that controls the baseband. But every other function of that phone, whether it's the screen or the camera or the Wi-Fi or the GPS or the accelerator or the battery and the power management, on and on and on, is a foundational chip. Without those foundational chips, you do not have an iPhone. You do not have most of that functionality that we've become accustomed to. So when you think about foundational chips, in many ways, they're akin to steel and aluminum, those foundational materials that, despite the invention of more advanced materials like carbon fiber and the like, are still instrumental to the building of virtually everything in our world. Even if you look at some of our most advanced airplanes, be it military or civilian, like the Boeing Dreamliner, you cannot build them without steel and aluminum. They're fundamental to national security, and indeed, the U.S. government policy over decades has focused on ensuring a secure supply of those chips because of their national of those materials, because of their national security implications. The same holds with foundational chips. When you look at the impact to our economy, we have witnessed a severe shortage in the automobile manufacturing industry during the latter stages of COVID, that was driven exclusively by the shortage in foundational chips. There was really no shortage in advanced or leading edge chips. And yet, because virtually all the chips in cars are foundational chips, you had factories that were idling in the United States, dealerships that were empty, and half-built cars that were sitting on the parking lots at these factories, unable to be completed and sold, and having a significant impact on our economy. In addition, even as important as leading edge chips are, and advanced chips are, they actually cannot be built without foundational chips, because the equipment that is required to build those chips is built with foundational chips. And we've seen the impact of the foundational chip shortage on companies like TSMC, declaring in the last couple of years that they have had issues in expanding capacity at those factories because they were not able to procure equipment, and that equipment could not be built because of the shortage in foundational chips. So these chips are literally essential for everyday life, and indeed are the majority of the market. The vast majority of the market is foundational chips, not advanced and leading edge chips. But more crucially, if you look at history, and if you look at, for example, how TSMC has become a critical leading edge and advanced nodes manufacturer of chips, their history shows that they started out with focusing on foundational chips and building up expertise, training up their people, establishing critical customer relationships, generating revenue that eventually led them on a path to establishing dominance in the advanced leading edge market. So foundational chips are really also a gateway to the advanced and leading edge capability. And that is one of the concerns that we're highlighting in the report that we'll discuss, that as China builds up a massive advantage, including by using price dumping in that foundational chips market, that it's going to actually not just help them establish a dominance in the vast majority of the chips industry, but it's also going to help them get better expertise and better capabilities to also eventually advance to the leading edge side. So with that, I'm going to one last point is the recent news that Huawei has been able to produce a 7 nanometer chip that was manufactured by SMIC. Indeed, most industry analysts believe that that chip was being manufactured by equipment that is typically used to manufacture foundational chips, like DUV machines, for example. So that capability could actually the manufacturing capability and the advanced process knowledge that is required to build foundational chips will help you also get to some of the advanced nodes. You probably won't be able to get to 3 nanometers or 2 nanometers, but 7 certainly has been attained by SMIC so far. Some industry analysts believe that 5 nanometers might be achievable as well. And those chips are going to be very, very good and very competitive in a range of applications. So that knowledge of manufacturing foundational chips can directly lead to some of the applications in the advanced space as well. So with that brief intro, let me turn it over to Sarah and the team to go through the report.
Thanks, Dimitri. We've got a presentation here that Andy David is going to walk us through. Most of these are charts that you will see in the report itself, and each slide indicates which page number of the report that you can find it on. So, Andy?
Great, thanks, Sarah. Before we get into the findings for the report, I'm just going to walk through the methodology we used in the report. So first, we relied on publicly available data for the report. So this is some advantages and everything in the report. It's very transparent in where we got the data, the sources. You can track back for most of it from where the original underlying source information. Disadvantages are we don't have the perfect data set for everything we're trying to look at in the report. And that's kind of clearly marked as you go through and read the report. We rely heavily on volume data. There's also some value data, but we use a lot of volume data because that better reflects what's happening in the foundational segment of the market. We cover the entire value chain in China from design through assembly, packaging, and testing, as well as some of the inputs into those processes. Our report covers all semiconductor products, so you won't see super deep dives on things like logic and memory. We touch on them, but we don't do a super deep dive into any individual products. We're trying to cover the entirety of China's semiconductor industry. And finally, when we talk about manufacturing in the report, manufacturing in China, we're talking about all companies manufacturing in China, whether they're Chinese headquartered firms or whether they're foreign invested enterprises manufacturing in China. Okay, so next we're going to turn to Chinese government policies. I'm only going to touch briefly on these. I think these are probably pretty familiar to most people in the audience. We do have several pages on the report. As Sarah said, you can see in the bottom right-hand corner of the slide where this information appears in the report. So there have been a number of CCP policy initiatives that have discussed the semiconductor industry. The Chinese leadership has a goal to indigenize the semiconductor industry. That's a key priority for them, as is often talked about, with the goal of 70% self-sufficiency in semiconductors. Policy support happens at all levels of the Chinese government. So it's not just the central government. We see local governments as well supporting the semiconductor industry. Collectively, that's billions of dollars in government support flowing into the industry. There are a lot of different ways the government supports the industry, everything from tax credits to direct subsidies, low price land, and so on. And we kind of enumerate some of those in the report. So first stage of the value chain is I want to touch on China's design industry. You can see here there's been a large increase in the number of design firms in China. And not only are the number of design firms increasing, but the capabilities as well. It doesn't mean that China's able to design all semiconductors within China today. There is variation depending on the firm and by the technology, but we certainly see both number of firms and capabilities having increased significantly over the last decade. Next stage of the value chain we're going to look at is semiconductor fabrication. So you can see here, Chinese integrated circuit production, the volume has substantially increased over the last decade. There's a little drop off in 2022 amidst weaker market conditions in volume terms, not really in value terms, but on the volume side. But overall, the trend has been a huge increase in production in China. In terms of capacity, China has the most 200 millimeter fab capacity in the world, and they're tied with the second most 300 millimeter fab capacity in the world. When we look at the foundational side of the market, we can see that more than a quarter of the node sizes that we show here, more than a quarter of production capacity is in China. When we look at memory, China is also a leading producer of memory products, not just the two products we see here, but some other products as well. Okay, so next we're going to turn and be a little bit more forward-looking and look at investments in semiconductor fabs in China and where kind of the direction of capacity in China is going. First, China has the most new fabs and major expansions planned through 2026. And you can see that here in the top bar. This will result in China having not only the most 200 millimeter fab capacity, but also the most 300 millimeter fab capacity. So China will account for a quarter of all global 300 millimeter fab capacity in 2026, according to current projections. When we go back and we look at the foundational side of things again, we can see that China is going to expand their lead in the foundational portion of the semiconductor industry, at least for the node sizes that we're looking at here. When we look at the memory side of things, it's a little bit different. You can see that China's share of memory is going to peak around 2022, 2023, and then decline a little bit, but they'll still be well above where they were historically in terms of their share of memory production. And these are only two products. There's also other products, as I mentioned, where China's a key producer, and we'll see that again in a minute. Okay, so next we're going to talk about a little bit about assembly, test, and packaging in China. And you can see that in this stage of the value chain, China accounts for almost 40% of global assembly, test, and packaging capacity. This is not just low-end packaging capacity. China is also moving into the advanced packaging space as well. So, so they're also a player in that key segment of the market. Next, we're going to look at exports. Not surprisingly, given the large role that China plays in producing semiconductors, we see that by value, they're the second largest semiconductor exporter after Taiwan. If we were to look by volume, China actually exports more semiconductors by volume than Taiwan does. So we see China also playing a big role in the export of semiconductors. Next, we're going to touch briefly on the supply chain. First, talking about semiconductor manufacturing equipment. So first, to set the stage a little bit, China's semiconductor manufacturing equipment market has substantially grown over the last decade, both in terms of the value of the market and in terms of the share of the market that China accounts for. China is relying on foreign technology for a lot of the semiconductor manufacturing equipment. You can see here, Japan, the United States, Singapore, EU are all key suppliers, not surprisingly, of this equipment to China. But China's domestic capabilities in semiconductor manufacturing equipment are growing. You can see here the significant increase. This is just a subset of the industry in China, 13 publicly traded companies. You can see how much their revenue has increased from 2021 to 2022. China's also relying on other imports of foreign technology. You can see here some of the larger wafer sizes China is importing, some of the photoresists, also some of the design software, other things. So China is still relying on foreign technology. They're certainly improving those capabilities, but there's definitely things that China can't do by themselves yet. So what are the impacts of China's growth? So the first thing we're going to look at is pricing pressure. So as a caveat up front, there's limited publicly available pricing data. So we talked up front about some of the limitations of only using publicly available data. This is one of them. But we were able to put together from anecdotal information, from limited kind of quantitative price comparisons, some information about the semiconductor supply chain. And we see that China has lower prices in all stages of the value chain. When we look at just the kind of final end semiconductor product, we see that Chinese products are 20 to more than 30% lower than the price of non-Chinese competitors. You can see here on the right a chart of the prices offered by Chinese distributors for a gigadevice product and a comparable ST micro product. And you can see that the gigadevice product is not always cheaper, but Obviously, in most of the price comparisons, the Giga device product is substantially cheaper than the ST Micro product. And again, these are very comparable products. Chinese firms account for a significant share of the market for some products. There's two examples up here, but in the report, we go through a number of different products, both in the text and in the Appendix B as well, have a number of market share comparisons. But you can see Chinese firms might not be the largest player, but they're certainly gaining significant market share for a number of products. And finally, think about what are the implications of this for non-Chinese producers. First, as the Chinese industry continues to develop and expand, there's going to be fewer market segments for US and other non-Chinese producers to compete in. As these sectors become commoditized, these major national manufacturers are going to be pushed out of some of those market segments. Second, semiconductor manufacturing involves high fixed costs. So as firms lose sales, they're going to have fewer units over which to spread those high fixed costs, and that's going to result in higher per unit production costs. Third is just lower revenue, which will of course impact long-term competitiveness if it affects investment in R&D and manufacturing. And fourth is, as Chinese competitors gain more experience in low-end market segments, they're going to, and we already see some of this today, they're going to move into higher end market segments. So just because they're in lower end market segments today does not mean that competition is not going to come to the higher end market segments. So with that, that's kind of a brief overview of the report. And I'm going to turn it over back to Sarah to kind of take us through the recommendations that are in the report.
And before Sarah joins, this is Mark again. Just want to remind everybody we're happy to answer any and all questions. Just please use the Q&A function, which should be at the bottom of your page. Go ahead, Sarah.
Okay, well, thank you, Andy, for all of your hard work on this report, as well as the rest of the team. I think it's really enlightening, and I think that most of the people who are probably listening today would agree that this is not an easy problem to solve. So when we think about recommendations, we've got to think comprehensively. We've got to think about a suite of options. So this is what we've laid out here, and we welcome conversations with all of you and beyond as we move forward with this, because I think it's really important that we get this right. So the first recommendation that we have is to be looking at how we can work with Japan and the Netherlands and some of the European countries who are the producers of the manufacturing equipment and tools that China is going to need in order to realize its ambitions to achieve these capacity expansions. I realize that this is difficult, it's unpopular, but I think it's a conversation that we need to have. You heard from Dimitri that there is a national security justification here. If we do it with partners and it's not unilateral, I think that that can really help to soften the blow for equipment manufacturers who are looking at China as an export market. But I think a big part of this too is looking at where are the new markets for that equipment and tools. We're making major investments here in the US, and the EU and other allies have also announced investments. So the question really comes down to not whether or not the number of chips produced will change, but who is going to be producing them. So we think that this is an area that should be explored. Secondly, the Treasury Department is looking at an outbound review mechanism. It's very nascent stages, as we all know. But this is another area where, similar to the export controls, Treasury should be looking at how can we prevent more investment in China's capabilities to produce these foundational chips. We want China to be reliant on the chips that we're making and investing in, not the other way around. At a minimum, we would support a disclosure requirement under any mechanism that Treasury comes up with, or the Hill for that matter, if they beat Treasury to it. The third recommendation really gets to the import side of things and thinking about what trade remedy tools might be brought to bear here. I think one sort of threshold matter that we would recommend to our colleagues at the Department of Commerce and beyond is, and if you're not already doing this, setting up a public-private monitoring initiative for foundational chips. It is hard to distinguish between what is a foundational chip and what is a leading edge chip based on our current HTS. So we have another recommendation that would allow us to get more granularity in our import data, but understanding what's coming in from China, not just to the US, but to other markets where US exporters are competing, is absolutely critical to understanding what the policy options are in this space. Is it an AD or CVD investigation, which, is not easy. If any of you have worked on these cases, you've got to show material injury to the domestic industry or a threat of. But there's other options. We have existing 301 tariffs. There's potential for a new 301 or a new 232. These are all the types of options that we can be looking at, but it starts with having the data and understanding what the threats are to our companies. The fourth recommendation really regards enhancing enforcement and penalties for forced technology transfer, economic espionage, and IP theft. Obviously, this has been a huge effort by the US government under many administrations, doing great work in this area, but it's pervasive and it persists. So we have to be making sure that our investigative and enforcement agencies are well-resourced and have the ability to not only identify where there are threats, but then enforce against those. The fifth recommendation may seem obvious, but it's actually quite a complicated issue, and that is using our federal procurement process to make sure that we're prioritizing US and allied foundational chips over those made by Chinese competitors. So we have a recommendation in here that GSA should take a close look at its list of suppliers and stop US agencies from being able to purchase products like printers and computers that contain these chips from Chinese firms that have links to the CCP or that are already on the Commerce Entity List or on the DHS Forced Labor Entity List. The sixth recommendation is to institutionalize a process for the annual release of public information on the global semiconductor industry, looking at, for example, not just analog, logic, and memory chips, but also the different dynamics that are happening at the leading edge and at the foundational node sizes for each of those chips. There's very limited data that is out there publicly. I know that there's some really incredible sources, but much of that data is behind a paywall. So we encourage our government and our allied governments to work with the private sector and try to figure out a way that we can get more of this data out there to the policymakers who are making really important decisions about the trajectory of this sector, sometimes without all of the information that they need. And the last recommendation, as I mentioned before, is to update our harmonized tariff schedule in the United States so that we can make sure that we've got the breakouts that we need to do the import monitoring that we need. So I will stop there and turn it back over to Mark.
Thank you, Sarah. We do have a few questions here. We're going to start at the top. The question is, where is China sourcing their wafers from, and where are they sourcing most of their chemicals from? Either Sarah or Andy, you want to take a shot at that?
Andy, I think we have some of this in our report, so maybe Andy can take this.
Yeah, so they're definitely importing some of their wafers and some of their chemicals. They have some domestic production as well. So they're importing a lot of this stuff from other countries in East Asia for their domestic needs. And as I said, they're sourcing some of it locally. So certainly for some of the more advanced products and some of the some of the larger wafer sizes, things like that, they don't have enough capability to do it domestically. So I have to look see what other countries we're not including, but I know a lot of it's coming from their other partners in East Asia.
Yeah,
Thank you.
primarily Japan is one of the leaders in the chemical production space.
All right, thank you, Dimitri. This next question is to you. What do you think will be the implications for national security if China wins the foundational chip race? In other words, if they corner the market like they have in solar, steel, and other industries that we've seen them using similar practices in.
Well, that will make China. That will make the United States completely dependent on China for virtually all of our technology needs, whether it's in national security space, like our weapon systems, to our automobiles, to our TVs, to our cameras, to our iPhones, to everything literally that we have around us that is using chips. All of it is using foundational chips, and none of it could be produced without China. If we become reliant on them for foundational chips, it will give them just a absolutely massive leverage over our economy and national security, far beyond anything that they have today. It literally would be an equivalent if China had the vast majority of steel and aluminum manufacturing in the world and no one else could produce it. That would have really dire implications for the security and independence of our own supply chains. This would be akin to that.
Thank you. Next question from Greg Bowman. This is mentioned, he commends the report, and he asks if we can expand upon the impact of software and the Chinese ability, especially in the area of electronic design automation software. There are only 3 major companies in the world that make this software for advancing in foundational semiconductor manufacturing. So can you expand on the impact of them having the software?
Yes, certainly there's, as the question states, there's 3 major companies that supply this software. Chinese companies use the software, as do others. China is certainly improving their capabilities in this area. The Chinese firms that do this are not among the leading global suppliers. They're not, they can't do everything, but certainly China is improving their capabilities in this area. But right now, those 3 companies continue to dominate the market for that software.
Thank you, Andy. Next question is, how significant has foreign investment in China's chip industry been in the rise of its capacity? How significant is it today? And who are the most significant foreign investors in this sector? Dimitri, you want to take that one?
Yeah, so it certainly has been absolutely essential to the start of the China's chips industry. In fact, when you look at their national champion in the space, SMIC, they were in large part started with critical investments from Goldman Sachs back almost 23 years ago. So it has played a role in the beginnings of this industry. And obviously from an equipment perspective and expertise perspective, it has also been essential because no Chinese fab can be really run today without equipment from companies like ASML, Applied Materials, Lam, Tokyo Electron, Nikon, and the likes. And you've seen lots of people that are American green card holders or American citizens or Taiwanese citizens going over to China, helping to set up these companies, helping to operate these companies, share the knowledge of how to optimize processes. So both on the money side, on the equipment side, on the expertise side, foreign investment has been essential to the Chinese chips industry. And I think that industry would be nowhere near where it is today without that investment.
Right, and China's committed hundreds of billions to this project over the years and multiple 5-year plans. Next question is, what, if any, role does Latin America have in terms of broadening the semiconductor supply chain and nearshoring it closer to the United States? In other words, friendshoring, nearshoring, reshoring. Any Sarah or Dimitri or Andy?
I can kick us off on this one. I think it's absolutely critical. And I think it's critical not just to the role of the semiconductor supply chain, but some of the upstream inputs, such as critical minerals. I think, Latin America and Western Hemisphere more broadly is an absolutely underappreciated region at the moment for some of our policies. And we would love to see more focus there by the administration. We have many FTAs with partners in the Western Hemisphere that are, quite old at this point, but still provide very advantageous tariff and investment benefits to partners that are trading together in this hemisphere. And when we're talking about supply chains like semiconductors or critical minerals, having more investment closer to where we are already seeing more investment in manufacturing capacity will be very helpful down the line. We're seeing this as a trend in Asia, where there's a lot of production capacity in China. You tend to co-locate other portions of the supply chain there. So now as we're thinking about more investments in the US through the CHIPS Act, we should be thinking about co-locating more segments of the supply chain closer to that new capacity. And it's a great region to do it in. Lots of economic and strategic allies. And as I said, already have, I think, 12 of our 21 free trade agreements with partners in the region.
All right, thank you. All right, the next question hits on a couple different points. So I'll read the question, and then Sarah, I'll throw it to you under your USTR trade negotiator hat, but Dimitri and Andy, feel free to jump in. Historically, in China, the Chinese factories run by the military have formed the core of the semiconductor industry. Do we have insights on the military's involvement in production today? This has relevance to the possibility of coordination among allies. And then it talks about a export control committee that was dissolved in '94, and whether there's a replacement mechanism for coordination today. Sarah, do you want to start out on that one, and then others jump in as necessary?
Yeah, I think that this is a great question. I don't know off of the top of my head exactly the level of involvement, but obviously there's a huge level of involvement between the Chinese government and the PLA and all of the money that's going to Chinese firms in this sector. So I think that's why you see this, civil military fusion becoming just such a big cause for concern. I don't know how that trend has changed over time. It's something for us to look into, but certainly there's a lot of ties there, which make this that much more concerning.
And obviously, they're key suppliers for the PLA as well, which has its own implications for the modernization of the Chinese military.
All right, well, that's the end of our questions. So I want to thank everybody for joining us this morning. And again, if you have any questions that come up, feel free to send us an email, info@silverado.org. And I'm going to open it up for some last comments from our panelists. Dimitri, you have anything in closing?
Well, just again, to reiterate, foundational chips are essential for national security, for economic security, for our way of life. Maintaining our position in the West of being able to have independent production of those chips is absolutely essential, just as it is essential to deny China the ability to produce advanced chips for purposes such as training and running AI models, which the administration's export control policy is implementing. We need to have the same focus on foundational chips, because indeed, even in the AI ecosystem, you cannot build AI models without foundational chips. Yes, GPUs that you typically use to train those models are done with some of the most advanced nodes, but the servers that those GPUs go into, because the chip by itself is quite useless, you actually need something that you're going to run that chip on. The power management, the networking, all of those capabilities that actually make the entire system, the entire cluster work, are based on foundational chips. So they're absolutely critical to every component of our life. And we need to make sure that Chinese expansion in this area, as well as their dumping that they're engaged in through price fixing and subsidies, is not undercutting the critical investments that taxpayers are making through CHIPS and Science Act and other government policy.
All right. Well, thank you very much for joining Silverado Policy Accelerator's rollout of its newest report. And again, reach out to us if you have any more questions. Thank you.